a hemoglobin H disease and not even know it. And that there's kids would be more likely to have a thalassemia major because they've passed on 2 non-functioning or 3 non-functioning genes. You see how that works? Okay. Getting very little head. Anything. I'm going to start looking at you.
I'll do the water shoot for you every time.
I know. I'm trying to get something off you guys. Anyway, so beta thalassemias. Beta thalassemias, this is a mutation on chromosome 11. And this is one here, I mean, it's right next to chromosome 16. There's only 2. There's only 2 genes for this one. And these are very diverse in the way they present. They could be point mutations or deletions, and so that causes a lot of diversity in the way these patients, with all the ways called heterogeneity, in the way these patients present and how severe their disease is. But basically, you don't produce enough beta globin, right? So now you have too much alpha. For the beta thalassemia trait, these patients, they have just a slight decrease in beta globin, but not enough that they actually feel symptoms generally. They don't actually have that much, maybe a little bit of slight anemia, which could be easily attributed to something else. And intermedia is a little more significant. These patients might actually have bony deformities because the bone marrow is trying to put out so many red blood cells to replace defective ones. The other thing is, in the thalassemias, sometimes they're so odd. For one thing, the red blood cell breaks down after oxidation. That kills the red blood cells. They also have inclusion bodies. I know that sounds, they start to, they have some DNA remnants sometimes. They call them inclusion bodies. And sometimes macrophages will see those and kill them, like eat them up. So they actually have a little bit of hemolysis in thalassemia too sometimes. So just so you know, it's not really important, but it can decrease. It makes their marrow try to put out lots of red blood cells. These patients can have bone marrow difficulty or bony abnormalities. With these patients, if they can't keep their hemoglobin levels high, then you need to consider a transfusion, and then also splenectomy, right? Because they have these oddities in their red blood cells, the spleen is like, we gotta get rid of these puppies. And so these patients will lose more red blood cells than they need to, and the spleen is responsible for that. And if you can give them a splenectomy, sometimes that will regulate itself. Especially if they need a transfusion, you need to consider how much of a role the spleen is playing in killing these red blood cells. And beta thalassemia major, these people don't have any beta globin. They will definitely have an enlarged spleen. They will not be able to make much hemoglobin, so their red blood cells are hypochromic and they'll have severe anemia. These people have to have transfusions. They will from the time they're little. Now, the thing with beta thalassemias is, I'm sure, did you talk about how you have fetal hemoglobin? It's a little bit different than an adult. So like 6 months in, right, you start producing more. So these patients, they will have more fetal hemoglobin than the general population. And many times you won't even notice symptoms for quite some time, even people with beta thalassemia major, until that fetal hemoglobin starts to decrease in concentration. But certainly by the time they're toddlers, they will be required to have transfusions. And because they have lots of iron, these are often coupled with chelation therapy to keep that iron in check with desferoxamine. You don't need to remember that, just chelation therapy. Okay, so laboratory findings in thalassemias, they'll have the persistence of the hemoglobin F, which is your fetal hemoglobin. On peripheral smear, they'll be hypochromic, they'll be small. This is a microcytic anemia. They'll have some nucleated erythroblast. That's because we're trying to turn them out as fast as we can. And then target cells. I'm trying to see, there might be one target cell in there. See that little one with a dot in the middle? That one, the target cell. That's not normal. That's pretty good indicator. Now the problem is, so many of these peripheral smear findings show up all over the freaking place. So don't spend a lot of time memorizing how Jolly bodies go with this, they go with that, because they're not specific to one disease. You have to put it all together as a picture. I love hearing that. Serum iron and ferritin, those are above normal. They have lots of iron, they just can't use it. Their hemoglobin's low, and if your confirmatory test is your hemoglobin electrophoresis, that's how you're going to determine what you're dealing with here. So treatment, do not give iron. We don't want to give these people iron, right? They already have high iron. So that's one reason why we want to know the difference between this and iron deficiency anemia, because the treatment is potentially deleterious for these people if you did treat them like iron deficiency anemia. Many times they need folic acid to help them create cells. They also start to get, almost like any other disease where they start to throw out cells as quickly as they can, you start to get a deficiency in any of the building blocks. So many times folic acid is one of those. You don't give them iron, but you don't give them oxidative drugs. There's a long list, you can look it up. Sulfose is one of them, sulfonamides. You don't want to give these people oxidative drugs. Thalassemia major, they'll need transfusions, genetic counseling, and then the splenectomy. Anytime you give somebody transfusions, certainly repeatedly, you need to consider if they need a splenectomy. Bone marrow transplants, they're great, but you have to be a perfect match. If they can find a perfect match, they do really great things for these patients. They really do. So it's certainly something to think about in either of the major thalassemias. All right, we have one more section. All right, can we continue, or do we need a break real fast before we go? We're going to break? Okay, let's do it.